Okay, this is officially lecture number 1, and I'm going to speak as loud as I possibly can so this recording quality looks good. Who knows, or sounds better. So what you're looking at is a website. The website you're looking at is edrplus.com. If you have a computer, go to this website because we can interactively go through the lecture and practice entity relationship diagramming and learn how to actually do it all in one shot. Which is what I'm going to demo. So this URL up here is www.erdplus.com. If you want to, you can bookmark it or you can Google it if you can't find it. So it's ERD Plus. Actually, let's see if I do that from here. Google. Actually, anyhow, I'll just type it in this way, make sure it's correct. www.erdplus.com. Takes me to this website, erdplus.com. Entity relationship diagramming. This is a methodology and a tool set to use to model databases, which is what we're learning in this class. So this is the tool set. It's absolutely free. There's nothing to sign up for. It's web-based, which means you need internet access to use this tool. If you don't like this tool, you don't have to use it. You can do everything we're doing by hand on a piece of paper and a pen. I wouldn't use a pen, though. I'd probably use a pencil and an eraser because it's an iterative process and you're going to want to move things around. And the problem with a piece of paper and a pen and some of the other drawing tools is you keep having to erase stuff and move stuff around. I like this tool because you just pick things out and you drag and drop them. We're going to see that in a few minutes. What we're creating are entity relationship diagrams. That's what this ERD stands for. The plus, I don't know what this plus stands for. Maybe it's the automation you get. The plus is, I don't know. Maybe it does table translations for us. Who knows? What we're doing is database modeling. And you're like, this is day 1 of the database class. We're already going to do modeling? Yeah, why not? And I'm going to talk about basic database concepts as we start doing our modeling. And it's easier to do it this way for me personally than it is to bore you with hours of lecture about database theory and then start modeling. So I just like to jump right into the modeling and then we'll see how that works. So on your leisure, you can go through the website and take a look at stuff. This is what these models look like. This is what the diagrams look like. And this is what we're doing. And you're going to see yours is probably going to look very similar to this. This tool is great because you don't have to draw perfect boxes and circles and things, and you pick out the items. There's only 3 items on this diagram: entities, relationships, and attributes. And I'm going to go through that today. And by the end of the day, you'll be an expert on ERD diagramming. I'm not going to cover all of it before lunch. We're going to start it. We'll see how far we get. But I want to talk about the theory. This is how we design databases. And there's a little bit of tutorial stuff. If you're interested, you can read through the documentation on the website. If not, you can skip right to the tool, which is what we're going to do. Don't worry about this stuff down here for relational schemas. Oh, it does do this. Look at that. You can create the tables right from the diagrams. What we do is we look at the requirements for a database. And I'll talk about that as well. Usually companies have things that they want to keep track of. They want to store data on certain things. A database is a persistent storage of the information. Most people are familiar with databases because you're familiar with the internet and you've probably purchased something. Maybe you've gone to Amazon, maybe you've gone to Barnes & Noble, you've bought something on the internet by now. If you have, you've been using a database. You've been using a database when you perform a internet search, actually. But when you go to a website, as an example, and go to Amazon, and you search on something, there's a query that's running from the information that you're putting into a text box. And that query is going to go out to a database. It's going to pull the information. It's going to take the information and come back and populate the page with it. Somebody had to design the database so that the information can be found, which is the design component. So when we start designing databases, we're concerned with logically separating out the data into different buckets or different tables is what we're going to call them. And then we're going to run queries on the tables. So the concept is kind of weird. And this is relational database concepts. This is the beginning part that I'm going through. In terms of the concepts, we take all this data and we separate it all out into separate buckets or separate tables. We logically organize it all separately, and then we put it all back together. And like, well, why in the world are we taking it, spreading it out all over the place, and then we're putting it back together? It's like counterintuitive or something. Why don't we just leave it all together? Problem is, when we leave it all together, we don't know what we have. If we separate it out into different tables, we can keep one piece of information about one thing, and we can keep that consistent. Which means, for example, students who are taking classes at the university. If we have your student data in one bucket, one table, we don't have to keep repeating it in every single one of our other tables, or every time we want to use it, we just go to the student table and we find your student ID, and we use all the information that's associated with you that we have. Like, we know how many classes you've taken, we know what your GPA is, we know all a bunch of stuff about you from your student table. And we don't have to repeat it. We don't have to move it and store it somewhere else. So we only want one piece of information per each individual student about each individual concept stored in one little table. And then we link it. We link it with keys. These are constraints on the database table that allow us to put all that separated data back together. And if that's the case, then it's the key structure and the constraints we put on the how to link it back together that's part of the design, and then it's the separation of the data that's part of the design. So when we do entity relationship diagramming, we're separating out, we're designing the separation of the data, how we want to divide it out, to store it, so that when we put it together, everything comes together nicely, everything's findable, and we only have one piece of information. We don't want more than one storage of something, because what if you move? What if you're a student in the university and we have your information stored everywhere, and then you move? You're like, I don't know, everybody moves. You get a new apartment or something like that. And we change your address in one table, but we don't change it in the other. Now we have two addresses for you. How do we know which one is the real address? We don't know. Or how do we know which phone number is the most correct phone number? We don't know that either. Not only that, now we have two pieces of data being stored for you. You're taking up memory. So the problem with databases, if you think about all the books out there in the world, how many textbooks there are, how many students there are, how many pieces of entities or objects there are, there's a lot. If we store one piece of data for each one that we want to keep track of, that's not very much. Times it by 10 for each person, then it's overwhelming. So there's this concept of big data that comes out of databases. And I'm sure you've heard of big data. Maybe not. Big data is what happens when you have databases and more databases and more databases. And you put all those databases together, and it's too big. It actually, if you walk away, you learn what big data is, because big data is big data, just like it sounds. Too much data. You can't query the data. The data doesn't get logically linked together. It was never designed like a relational database concept, never designed to actually work with itself. You're designing a relational database so that the data can work with itself. It knows about each other. It knows how to, you can bring it all together. Versus the big data concept where it's out there. And big data is, seriously, it's just a lot of data. It's big. And it's not all the same. It's heterogeneous data. So it's not homogeneous, which means it's not a relational database with a relational database with a relational database, and so on. Instead, it's an object-oriented database with a relational database with a repository of data sets or something, with data mining data, with this data, that data, email data, video data, web traffic data, tons of data that's not all the same, not in the same format, that can't be brought together using traditional database techniques. Then you have big data techniques, other algorithms, other methodologies to organizing the data. And then you have platforms and systems that you use to work with that kind of data. This class is on databases. Smaller version of big data, more manageable. You usually start with a smaller version and then grow it into a data warehouse or into big data. So this is the minute, kind of lower level data, easier to organize data. A company would have a database. We have many databases actually. The government would be putting all of those company databases together. So when you go to Barnes & Noble, as an example, and you order a textbook, yeah, they're usually coming from publishers' databases. And you're running a query on the publisher database to see who's got the book, what book is out there, what author is it. The ISBN is normally the search criteria, which is going to be the key that's going to get you the right book. And then you're going to get a query back that says, well, we have one of these in stock, or we have two of them in stock. Or better yet, these guys over here who are selling it used have a couple copies of it. That's a database application. It's a database feature. So that's where we're going to in terms of the bigger picture. And to design the system to make the database searchable, that's where we're starting from. So we're kind of trying to figure out how to make, and just keep in the back of your mind, because when I get into ERD stuff, you're like, how in the world does this relate to databases? What in the world are we talking about here? We are talking about databases, but this is going to be a methodology that I'm going to get into that's all about design. And then when you figure out the design, then the aha moment comes into place when we translate the design into the table schema. So what we're doing is starting with this kind of look, and then we're going to turn this into a set of database tables. And this tells us exactly what to do. So in the real world, if we were a database architect, we would create this, give it to the engineer, and the engineer will put it together. The engineers know how to read this. It's a diagram. So it's just like an architect for a house. Here's the layout. Here's where the walls are. Here's where the power and the water and everything go. Same thing. This is a little easier, though, I think. You can learn this in a database class. You got to go through like 4 or 5 years of architectural school in order to learn all the other stuff. And if you think about it, I don't know, some of you might come from an electrical engineering background or something. Same thing as a schematic that you're going to do for a board design. You're going to use a CAD or something. You're going to use another design tool meant for the other technology, and you're going to put electronic circuits together. Or you're going to give the board layout with all the components and all the spacing and all the lines and everything that you need in there. That's just another diagramming tool with another topic area. So in the world of databases, this is the tool you get. So there's tons of software you can download for this. There's a lot of paid for stuff. If you're on a Mac, a lot of people have heard this program called OmniGraffle. OmniGraffle is not bad, except for it's kind of expensive. If you're working in a real company environment, you might have OmniGraffle. Actually, let me see, make sure I'm saying this correctly. Here, I'll just Google it. OmniGraffle, there it is. There's a free version of it. You don't like working on the internet, don't worry about it. You can actually download and maybe OmniGraffle, use it. It only works on the Mac, though. This is good for people who like to create floor plans. You know, like, okay, so some people like to remodel houses. Some people like to do floor plans. You know, you're opening up a new store and you want to know where your displays and the entrances. You can use it for network diagrams. You can use it for corporate org charts. You can use it for entity relationship diagramming, object-oriented diagramming. It's a more full-featured program. It comes from a very low-tech version of Visio. If you've ever heard of Microsoft Visio, oh, that's a nightmare. I would not use that, actually. Unless you're sadistic and you just... If you come from an engineering background, you're probably familiar with Visio. Or some of those other tool sets. So what we're doing is using one for business people that's designed for databases. That's the ERD Plus that we're looking at. I chose that one because it's web-based and it's easy. All it does is entity relationship diagramming. If you download this one and use it, there's a 30-day trial. You don't have to. If you want to try it out, it's not bad. The only problem with this one, well, you have to pay for it after 30 days, but you can do everything. And because you can do everything with it, it's hard to find what you want to do with it. You know, it's hard to know if you're going to be, you know, looking at an entity. How do I get to the entity relationship diagramming tool part of it? Is the biggest confusion with this one. It's in there. You just got to go find it. It's not as straightforward, not as easy, and it costs something. So, Smart Draw is your other choice. It's another one I've used in the past. Again, it's very similar. Smart Draw. There's other programs out there that work on the web as well. Here's Smart Draw. Smartest way to draw anything. You know what? You don't want to use PowerPoint. You don't want to use Microsoft Word. Because, have you ever sat out there in paint trying to draw boxes and stuff? None of the boxes look like the right size. It just looks ugly. And these tools just make better looking boxes. So, and we'll see how this works. So I don't recommend either one of these. I mean, I do recommend them, but I'm not saying you have to get them. ERD Plus running from the web is just fine. If we're going to use ERD Plus, what we're going to do then is go down to the bottom, and it says sign up. You don't need to sign up. Unless you want to store your items online, you don't need to sign up. Instead, you could go standalone. No account sign up is required, and you save and open documents from your own computer. Think about it. You probably want to keep this diagram that you've created for homework assignment number 1 on your own computer, because you're going to want to submit it later. You leave it online, you're going to lose it. Well, you might not lose it. If you lose your login, you're going to lose it. You're going to want to keep it anyway. I'm going to show you how to do it today, so you'll know how to do the assignment. So this is assignment number 1 we're actually working on today. So standalone. You click on standalone, you get to here. I actually bookmarked it already. The software, I just want to kind of run through a couple of things on it just in the beginning so we know what we're working with. Over here where it says diagram, this is going to be like your open diagram, save, export image. You can also do a screen capture. It saves it in a PNG, which is not bad. The files that you turn in are going to be graphic files. There's no such thing as an ERD plus file. Well, there is. It's an XML file, but don't worry about it. I'll show you in a few minutes how to, when we write something, we'll put some stuff together. Then you'll see how everything works. When we create a document, what we'll end up doing is selecting things and adding it and creating and labeling and stuff. And I'm going to show you that as I go through the PowerPoint lecture. So this one here is lecture number 3. I'm going to talk through 1 and 2 as we go through it. But lecture number 3 is really the start of the diagramming. So if you came in a little late, you haven't really missed anything, because this is really the start. All right. So here's what we're doing. We're modeling databases. ERD is a modeling methodology. Kind of like UML is to object orientation. If you're in my class tomorrow, I'll talk about UML. But this class is about databases. So entity relationship diagramming is where we're going to start. It's a diagramming technique. That's all it is. And a design technique. So it's not bad. Here's a scary looking one. I thought the ones on the website actually were a little easier to look at. This is the same thing. This is done in Visio. Kind of complicated looking. It's not so bad. It's just scary to look at. I hate showing this one to students and then they go, well, you look at it now and then look at it actually at the lunch break and you'll understand more about it, so it won't look as scary to you. Because by the time we get to the lunch break, you're going to have a better feeling about all this anyway. So hopefully. It's typically usually what happens. What we're doing is looking at it from an architectural perspective. It's from a conceptual view. You know, when you think about it, here's your philosophical question. What does a database really look like? It's kind of like, what is a, it's not a physical thing you can actually look at. You can look at the data in the database, but how do you know what the database actually looks like? And that's why people, when they sign up for this class, go, databases. Oh, great. I don't know anything about databases. What do they look like? It's not like a Word file or a PowerPoint file, and not even like an Excel file if you think about it. A lot of people think that it looks like an Excel file because they download it and they use Microsoft Access. Access sort of makes it look like Excel. It's not. Anyway, what we're doing is you're gonna know what a database looks like by the end of, before we get to lunch, because you're gonna see what an entity relationship diagram, that's the database. That's what it looks like. You're like, really? And there's tools where you can, in fact, Oracle has this, and so does Microsoft Access, where you design the table schematic, you put everything in, you click a button, and it creates the tables for you. Are you in the database class or the systems class? Systems class. Great Sophia, down the hall. I knew it. So, you click a button, it goes from tables to entity relationship diagram. And then there's other tools where you put the data this ERD Plus actually does this. You create the diagram, press a button, it creates tables for you. So tables, diagram, diagram, tables. Tables are the implementation, programming part of it. Not really programming. You don't even have to do it. It'll be created for you automatically. But down the hall this way. And then make the first right. And then go all the way down. Huh? No, it's this building. Other side of courtyard. Anyway, I'm so sorry about that. Art and science, good judgment leads to good design. Without any design, bad judgment. There's a lot of people that just throw darts. I call it throwing darts. I'm going to skip through this stuff here a little bit. I call it throwing darts because you don't really know what you're doing. You just kind of make this, here, make that, here, make this, make that, make this, make that, and then you have all this stuff. It's kind of like if you've ever tried to organize your garage. This is just like organizing a garage or a closet or a room, if you think about it. A lot of people like to shove everything in there. It's like, oh, here, just put this here. Oh, it fits over here. Put it over here. Put it over here. Without any logical design to it. And then you know that you're not utilizing the space correctly when it doesn't all fit. And then you can't find what you're looking for. Or the desk is impossible to sit at because it's too close to the wall. And you know that there's a problem with the design. So if you start with the design of the database first, and you organize everything into different components, and then you put it together, it's more usable, which is why you follow this methodology. Generally, when you go to a company to work for anything having to do with the database, they have the ERD model, hopefully, and it doesn't look like a big old spider web. Hopefully, it looks like a decent model, and then you know what you're building your application around. You know what it looks like, so you're getting the conceptual view. 3 items on this model: entity types, relationship types, and attributes. That's why it's called Entity Relationship Diagram. E stands for entity, R stands for relationship. D is diagram, ERD. So now you learn something new about databases. So I could walk away knowing that. And there's only 3 things you're putting on here. So what's an entity? Entity is a person, place, or thing. Tomorrow I'm going to tell you an entity is an object if you're in my object-oriented programming class. Object. Everything's an object. Everything's an entity. Chair, a table, a student. So we first identify entities. And what I'm going to do is I'm going to start out and I'm just going to create a diagram that is about, and this is where I'm going to kind of go like this here, and I'm going to get rid of this one and flip back and forth. Make this one a little bit bigger so it kind of, I want it to fit. There we go. And go to this toolkit that we just looked at. And I'm going to start a brand new, and you don't have to do this, but if you want to do this, you can. I'm going to go new ER diagram, because we're not going to make today we're going to look at this new ER diagram. Next time I see you, we're going to look at relational schemas. So today's all about entity relationship diagramming. So I'm going to click on new, and I get this little thing out here. First thing I want to talk about is the entity. So I'm going to take it, I'm going to drag an entity out here. Or I click on entity, and I'm going to click out here, and I get an entity. So what I'm doing right now, and I'm just going to stick this in the middle, right here. And it says entity on it. And you're like, what's an entity? Person, place, or thing. There's a concept of an entity with a physical existence, and then there's one that doesn't have a physical existence. Like what? The objects you can see are physical. People, I don't know, chairs, tables. And then there's a concept, a sales invoice, work experience. This drawing is kind of a concept. So don't limit yourself to only things you can see. So if we talk about students, we have an entity, and up here on the top, on the right-hand side of the screen here, there's like this little spot here where you could put a name in. And I'm going to write student, singular, student. Up there, and you can follow along. You can do this as well, and you have this to save on your computer. Otherwise, you can go to the video and watch this later. And we have different entity types here, and we have regular, which is strong. See, this is a tool set made by a third party. I'm giving you database theory from a textbook perspective. Usually, entities come into 2 different types: strong and weak. A strong entity is one that exists on its own. What does that mean? Students, you're a single entity student, and everyone in this room is an occurrence of this student. So, like student number 1, student number 2, student number 3, student number 4. You're all what are called entity occurrences. But the concept is that from a conceptual perspective, you're a student. And then I'm a teacher. So I'm going to put a teacher on here too. So I'm going to click on entity again. And I'm going to stick one here. I'm going to put teacher up here. I'm going to name this one teacher. Today, right now, we have 2 teachers going. We have Donna, she's in another class, and we have me. We're 2 entity occurrences of the 2 classes that are running right now. It's summer. There's only 2 classes running. It's kind of a small program. But teachers are teaching students. I'm teaching you about entity relationship diagramming. The other class is teaching them about systems something. So we have a relationship. Uh-oh. I didn't know you were going to start having a relationship today, but you do. I have a relationship with you all. I'm teaching you database stuff. And you have a relationship with me. You're taking my class. And because you're taking my class, you have to do 7 assignments. You have to show up. And you have to listen to me talk. But I'm going to let you go for lunch soon. So that's our relationship. And you're like, well, okay. So that's the 3rd component that ties us together. And the relationship is what ties us together. So if that were the case, then the teacher, and if I go over here, I have one of these things that says relationship on it. And I can click on the relationship. And I can click in the middle of teacher and student. Right? And I can say, well, okay, I could put a name on this relationship. And the relationship right now is teaches. Teaches. Teach. Teacher teaches students. And then the next logical question, and what we're learning is how to diagram. We're learning the diagramming technique. And I know I'm going on a slow slide, but this quickly builds, which is cool. So if the teacher teaches students, I click them together by clicking on this relationship that I just labeled teach. I can call it anything I want. In fact, I can flip this around and I can say students learn from teacher. Or better yet, students take classes. Oh, classes, that's another one. So I can click on entity, click over here, and call this one class. Because aren't you really taking a class? This is a class. So now I have students, I have teachers, and I have a class. I could put them in any combination that I want. I can move them around. This is why I like the tool, actually. If you're doing this on a pen and a piece of paper, it's like, okay, I'll throw that away. Let's try it again. Every time you move these things around, you end up having to like start with a fresh piece of paper. So I have these 3 entities, and I have this relationship that's tying the 3 entities together. They call this a 3rd degree. The reason why this guy is a diamond symbol is because let's add another entity. I'm going to put another entity out here. I'm going to stick it on the top here. And this one's going to be in a classroom. All those students that came to this classroom looking for the other class, and I told them it was in the other classroom, this is going to be the classroom. So I'm going to put here room. So I have a teacher. I'm going to move teacher over here because I want to start with the teacher right now. Teacher who's teaching students in a class, and the class is in the classroom. The most you're ever going to connect together is 4 entities and one participant. And then they call this participation. We're all participating in this relationship. And the relationship is all about teachers teaching students, a class, and the class is in a classroom. And the reason why this is a diamond set, because you see this little arrow here, this little point here, and this little point here, and this little point here. Well, we're going to connect them in a few minutes to show that the relationship belongs with each other. So if I click on the teachers, I can identify over here where it says entity number 1. And I can say, well, what's this? Teacher over here. Well, okay, so entity number 1 could be teacher. And then entity number 2, and I'm not going to get into this yet over here. I'm going to leave this alone right now. Entity number 2 could be the student. And see how that line got put in there all of a sudden? So now I have, and if I move it, you can kind of see my line kind of, and then people that are like me, who are like, everything has to be perfectly aligned. I'm going to move it so it's aligned now. Wasn't it a lot easier than drawing it? And then I can go back to teaches and I can say, wait a minute now. I want another one. I want to add, well, I want to put, let's simplify this for a second here. I'm going to take these guys out of the picture right now because I only want to talk. See, I can actually connect these 4 as well. But I really want to simplify this right now. So I said, going back to my original idea where it says teachers, they teach students. And the teaches relationship has these properties that are associated to it. And we have this word over here that says participation. They're all participating in the same relationship. So we also have mandatory and optional. Here I didn't specify anything yet because I want to talk about participation. If it's mandatory, that means every teacher has to teach students. If it's optional, it might be that a teacher may not be teaching students. It doesn't really apply in my case, and I'm not really worried about whether or not it's optional or mandatory. But if I say that it's mandatory, I get this 1 in here. This little line changes, and I'm just demonstrating the tool set for you right now. If I change it and I make it optional, I get this is supposed to be a 0 in here. If I were to zoom in and look at this, I have this little thing on the line that changes. I'm going to leave it on as unspecified right now because this is later. This is coming up later. But that's what this is talking about here. Cardinality. People that don't like that word cardinality. Otherwise, they use the word multiplicity. Multiplicity works too. Remember that movie Multiplicity? Oh, actually, a lot of people haven't seen it. It's kind of an old movie. I can't remember the guy's name. He's like overworked. He's like one guy. He's overworked and he never sees his family or his wife. And he says, you know what? I'm just going to clone myself. And he makes like 5 clones of himself. Has anyone seen that movie? No. If you're bored, it's like on Netflix. It's all over the place. Multiplicity. It has something to do with cardinality, which is the reason why I'm bringing this up. It's multiples of the same. So one person, what if you could clone yourself? This is what the guy does in the movie. He makes like 5 different clones of himself, and then one clone goes to work while the other clone plays around with his kids, and another clone like takes his wife out to dinner. And all of them, it's one guy, but he's like 5 clones to him. So they're all doing, because he can't like get everything done, and he's like stressed out. It's a really cool movie. The only problem with the movie, there's a catch on the movie. The clones aren't quite perfect. The cloning technique works for a while, and then all of a sudden, they realize that each one of these clones has a different part of the personality manifested in the clone. So one of the clones is like really stupid, and the other one is like I don't know, like ultra funny or something, or ultra like. It's like different parts of his personality got like focused in the different clones. So the sum of the parts is supposed to equal the whole. Anyway, it's a whole philosophical movie, but it's a comedy. It's a fun show actually. Bottom line, multiples. Multiplicity means the same thing in databases, which means we have lots of students. If this university only had 1 student, I don't think we'd be able to afford to keep our doors open. More students we get, more we can afford to offer classes. We only have 1 teacher? No, we actually have more than 1 teacher. They're not all the same. So more than 1 teacher teaches more than 1 student. Really on the multiplicity side, we're looking at many. And when we clicked on this little many button here, you see these things are, usually they call them crow's feet. It's like instead of 1 line, it's kind of small on my little screen here, but if you have it on your computer and you click on the teacher element, and the teacher teaches many students, and then on the student end of it, well, the students, there's many teachers teach many students, and there's many students that get taught by many teachers. And if we got that down, you've actually written your first entity relationship diagram. We've left out one thing though. We have entities, we have a relationship, and then we have these things called attributes. Attributes are simple. Attributes are simple. Let's talk about a student. Let's talk about a student for a second. An attribute about a student is something that describes a student. For example, you have an attribute. We're going to add an attribute to student, and the attribute to the student could be, let's say, actually here, I didn't add the attribute to the student, I just clicked on it. So let me get rid of this guy here. Let me delete that one. I'm going to click on the student. I'm going to click over here, it says add attribute. If I add attribute, I see a little line that connected to my student. I know that before a few minutes ago I added an attribute and I didn't connect it to anything, I just put it on there. Generally, attributes are connected to things. So for example, this could be your student ID. And then I can add another attribute, and this could be your name, let's say. And I can move these little bubbles out so they look like this. And then what are you going to have? You're probably going to have a GPA too. So I'm going to put here GPA. This is, attributes are everything we want to store about you. So you could go GPA. And I don't know, what do you have? What else do you guys have? And name, address. I'm not going to put all your attributes out here. I'm just going to put one more. Address. Address. There we go. So I got some attributes. Now I'm going to make some attributes for me. I'm going to say that I have an ID. I do, actually. I have a student. I have a teacher ID. And then I have a name. I'm going to put a name out here too. So you can have the same attributes for multiple different entities. This guy over here. Let's make this a little. I like to line them all up for some reason. I don't know. You don't have to. Like that maybe. What do I have? I have office hours, office location. So I'm going to put in here office. Oops. What did I do? Change this one here to office. Office. There we go. What else do I need? Office ID name. You guys get the point. Anything that I want to store about myself, I stick in here. Anything I want to store about students, I stick in here. Even the teacher's relationship could have an attribute to it. It could be a day, or it could be a time, or it could be something else actually. I'm not going to complicate things by adding attributes to this relationship yet, but just know in the back of your head that relationships could have attributes as well. And in fact, let's just put one in here. I'm going to say major. I only teach computer science classes, so I'm going to put in here major. So the reason why I didn't put CS in here was because that's a relationship occurrence. In fact, right now we only have 2 CS instructors teaching, myself and Donna, which would be 2 different instances of this scenario going on. And our major happens to both be computer science. Now, next quarter, we're going to have psychology classes being taught. And so we're going to have psychology teachers. Oops, accidentally changed office. This was teacher. Teacher. There we go. I knew I changed something accidentally there. Next quarter, we're going to have psychology and other classes being taught. I think there's some religious studies and there's some other clinical psychology courses and stuff like that that go on at this school. And if that's the case, then this major would be more appropriate. So you don't want to store an attribute itself, like somebody's name or somebody's major. Instead, you want to go back and think, this is a generic model that's describing the relationship that teachers have with students, and they're teaching in a subject area. So I could put subject. This could be subject, actually. It doesn't have to be major. It could be subject, topic. And then we're going to come back over here and take a look at this one here, and it says, well, there's a class, and then there's a room, So it could be a subject area, and then in the subject area of a class, there could be like two classes going on. We have databases and then we have systems. So we can add the class component to it. And then I'm going to make my life a little simpler here though. Oops, what happened? I know we're not part of this. What happened to my bottom piece? These guys are working, but this one's not working. I think my web interface, this is my complaint about the web interface actually. This one's locked, this one's locked. Let's save this before I lose it. The diagram, I can save my file. If I save my file, I can see I've got this XML looking stuff in here. If I come back and I look in my downloads folder, I should see the diagram. The other thing you can do, well, let me just talk about saving real quick. Because now I'm worried because I'm clicking on stuff and it's not being responsive. Which means I'm probably losing my internet connection or I'm having issues. I'm still recording, which is good. There's a couple things you can do. You can do a screen capture. Or you can do what I just did a few minutes ago and save it to a file. If I save it to a file, I should see it, actually. Save diagram. Let's just export image. If I export the image, transparent background, save image. Now it should be saved. Not going to be in my download. It's going to be in my downloads folder, by the way, from my browser. So let's just take a look here. And I'm on Chrome. I'm on Safari. Not in there. Where's it being saved to? Let's just see, maybe it's on my desktop real quick here. Well, I know it will show up somewhere. Actually, I can do this. Save image as. Let's just try this one real quick. I know it saved it somewhere. I'm going to put it on my desktop. I'm going to say test. There it is. Okay, good. You want to save the sucker eventually. And I know you can load it back in from an image and it'll put it back in to the same interface. But when you're doing this, this is a drawing tool. If you lose your internet connection, something like that, you can't save it. You can always just do a save as I just did a few minutes ago. And you're saving it. Or in the tool itself, I'm opening up different windows. So let's close this for a second. If I saved it and I go to open it, let's see what happens when I open it. Test. Let's see. Oops, not the right format, so that's not going to work. So let's see. Save diagram. Good question. I know it's being saved somewhere. In any case, the reason why I was trying to say, oh, now it's working. See, the reason why I wanted to save it before was because I was clicking and I wasn't getting any response coming back. Primarily concerned with losing this. I still have it, so I'm still good with it. But in any case, as we're working with the tool, and I'm going to go in through a lot more of the conceptual parts of this in a few minutes, we could, I'm going to move this down a little bit, we could add more items to our relationship, and if we do add more items to the relationship, the most we're probably going to add or in this particular case, the room and the class. And I'm positioning these now over here to say that our class probably has some attributes associated to, and I want to fill those in, and then I'm going to fill in, I'm going to attach the class and the room to the teacher's relationship, and then I want to talk about the big picture. So the class is probably going to have a code or ID to it. And I'm going to move this one down here, actually. And it's probably going to have, it's going to be part of a major. Oops, keep changing that. Class. I'm going to add something here. I'm going to add a major. Or topic, subject. Subject is what I called it over there. And this subject is different from this subject, by the way. The subject could be computer science. The subject here is a database class versus systems class. So this is keeping track of all instances of classes for us. And then, oh, this is probably going to have a teacher assigned to it. So I'm going to add an attribute, call it teacher. Let me move right here too. And the reason why I'm moving these over is because I'm going to connect this teaches relationship. So if the teacher teaches, and if I have a room, I could go room, and then I can go room with class. And this is going to tell me that I've switched the other relationship. So I know there's a way of doing all of them by adding another degree to it. And I have to remember how to do this actually right now. There is a way of doing it. I just switched it from here to here. I know there's a way of getting all 4 of them in here. Let's see. Teacher. No, I've gotten it back here. So, but this is actually a good illustration of a point though. If the teacher is teaching a class, I have this relationship. And I know that a teacher could teach students. But what I'm trying to do is actually connect all 4 of these together. And I know it's possible, I just can't remember how to do it. Add attribute, view, extract constraints, no. Identified, let's see. Maybe there's a multiple select. No, there's gotta be another way though. I'll figure this out at the break, but what, oh, here we have a recursive relationship, a teacher teaching a teacher. What I'm doing is playing around with the, teacher is teaching a teacher, it's recursive. The teacher's going to teach students, we'll put it this way. And then, let's actually, this is illustrating a nice point actually. I could put another relationship in here, and the relationship I'm going to stick in here would be that the classes are held in a room. So if I were going to put another relationship in here, I would move it out into 2 separate diagrams. And I would actually stick it out this way. And this is going to be takes place, or held. I know there's a way of getting all 3 of them together, and I'm going to refresh my memory on that at the break. However, for right now, just so I can continue with this illustration, held, classes are held in a room, so I'm going to go this way with it. But theoretically, I could go either way. So entity relationship diagrams are read left to right, right to left. It doesn't really matter what direction you read it in. So here I have held or takes place, and I'm going to go classes takes place in a room. And I can add entities to the room. And what I have here, and this is actually kind of turned into a nice illustration, 2 separate things going on, but it's all part of the same database. So in your database while you're modeling it, you don't have to put it all together. When you put it all together, at most you want to connect 4. In practice, in fact, this tool might not allow me to do 4 together. In practice, it's generally what they call a binary relationship. Because if you list out all the binary relationships like this, as the teachers teach students and then the classes are held in classrooms, then it's simpler when you put the translation from the diagram to the tables. If you put it all together, you have to read it twice because you have 2 and 2. So if I were to put these together, I would take the class and I would take the room and I would push it off of teach, which I know I can do. As soon as I remember how to do it. Actually connect. Connect actually might work. Yeah, I could do it manually this way. I don't necessarily want to, but I could connect them if I wanted to do it that way. But I already have it this way, so I'm going to leave this alone. Because this is correct as well. This is equally as correct as if I were to put classes and room off of the same relationship. Problem with this relationship is now it turns into 2 when it really is 2. For example, this class is in this room whether or not you guys are here or not. It doesn't have to be you here. And it doesn't have to be me here. the class is still going to be in this room. This room is still going to exist. The class is still going to exist. We could move the class into another room. For example, if maybe we had twice as many students, we could take this class, put it into another classroom. It still doesn't change the relationship of you taking the class. It doesn't matter what room you're in, is the question. If it doesn't, then these two could actually be separated. If it did matter, if you could only take this class in this room, like there's special equipment in this room, and that has to be part of the relationship. You can't take this class unless this class is in this special room. Then you would be mandatory. You would actually have to put it together. So you would have these having to be strung together. But because it is actually optional, this class could be held in any classroom we want. It doesn't really matter. We could leave it like this. This is more common to see as well. So going back to that, if we go back to that website, we look at that finished example that we looked at down here. Now this is starting to look a little bit, maybe a little bit. We haven't gone through all the cardinality and optionality and all the other parts yet, but now we see that products are sold via a sales transaction. And the sales transaction is bought, so customers buy via the sales transaction a product. Well, we could do the same thing with our diagram if we wanted to. We could add another relationship to it going this way. If that were the case, I'd move this stuff over here a little bit. Let's move it over here a little bit. So teachers teach students, and then students, what do students do? They get a grade. So you could add a relationship here. Relationship. You earn a degree. I'm going to put that, that's a better one. You earn. What do you get? You get a degree. Eventually, hopefully you're going to get, that's why you're here, right? I don't know. You're going to get a degree. Oops. A degree. And I'm going to put this between student, and I'm going to put it between degree. And then the bigger question is, well, how many students earn a degree? Any number. So many students might earn many degrees. Now I have the crow's feet going on over here. Many students earn many degrees. Many teachers teach many students. And I can move it over a little bit here. And those students earn many degrees. And then let's go back and take a look. This frightening diagram doesn't look so bad anymore. Because it's a product. It's a product tab. And I haven't gone over this unique yet. I'll go over that in a few minutes. But a product has a product ID. And it has a price. And it has a name. Don't worry about this part yet. This is mandatory and optional participation and cardinality. More on that later. This is the relationship. It's sold via. And they're like, well, why did someone say sold via, buy via? I don't like that. People make up words. I'd rather use teaches, earn. And then you're like, well, does it need to be earn or earns? The database people are not English majors. In fact, for the most part, a lot of people just make up. This is not a word, by the way. Sold via is not an English word. It's somebody's made up expression. So I don't actually like to do that. I like to actually use words, but that's because that's the way I am. But it doesn't really matter what you call the relationship. It doesn't really matter what you call the entity either. And you have just created, if you've been following along, a pretty equivalent diagram to what we just saw on that website in about a half hour or so. It's not that difficult. The more difficult part is understanding what data you want to stick in there. This is pretty easy. You guys are all familiar, let's say, with the university setting because you're all students and you're taking classes. You know where the classroom cells in a classroom, yada yada. This is pretty basic concept. But what if you're like a pet store? And you're in a pet store, and we can do this actually really, I'm not going to do it, but I'll just talk you through it. You have pet store, and then you have animals in the pet store, and you have cages for the pets, and you have food for the pets. And then you have bathroom services for the pets. The pets are going to go to the bathroom. You have cleaning cleaning that happens with the pets. And then you have people that buy the pets, and you have people that sell the pets, and you have pets that get returned. I don't know, can you return a pet to a pet store? I don't know. You have all these things that happen when you create entities and relationships between the pets. So customers buy the pets, pets poop in the cage, cleaning person cleans the cages. Other stuff happens in the pet store. You put it all out here, and then you realize that's the data I want to store. And then let's turn it around a little bit to database terminology. Well, I want to store information about the pets. Who's in my inventory? Well, that really turns into the pet inventory database. And the pet inventory database is why I have pigeons, and I have rabbits, and I have dogs and cats, and all this other stuff. And so you probably want to keep track of what for a pet, like species. Maybe the gender, is it a male cat or a female cat? Maybe how old it is. So you have all these attributes that you're going to store about all of the pets that are going to be an entity, and the pets are sold in the pet store. And the sold relationship might actually turn into a table of who bought what, and how much did they pay for the pet, and what day did they buy the pet on. Maybe there's a 30-day return policy that we need to keep track of or something. All the stuff that you're modeling is the real world. You take the real world model and you reduce it down into a set of database tables, and then you populate the tables with the information that fits into the scenario. Going back to our scenario, each one of the teachers is in the teacher's database. We're all recorded because that's how we're going to get paid. Each one of the students is in the student database. That's how it's recorded, because that's how you're going to pay tuition. So you can pay the teachers. We can map out the entire financial part of this if you want. All the classes and all the degrees. All the degrees have requirements for all of the classes you have to take. I guarantee it, there's a table in our database that has all the degrees listed with all of the classes needed for you to take. We have a table with all the teachers and all the students. We have all the relationships identified, so we have connections between all of these different things. And the reason why we're paying attention to relationships is because these relationships turn into storage components as well. As an example, if you didn't have a relationship identified between a student earning a degree, how would you know when a student actually finished the degree? If you weren't keeping track of degree completion relationship. Let's say, for example, you were a student and you went to the university and all you do is take classes. That's what you do actually. But in the case, what if we weren't keeping track of that relationship if you're taking classes? How would we know when you earned a degree? How would we actually be able to issue you a degree? So in our database, we have a progress. We have a transcript. We have the records that are coming from that relationship that we keep track of. We put it in here, so we put it in the database. So whatever you put in the diagram turns into the database data that you're capturing. In order to capture the data, you have to diagram the real world. So it's kind of weird. A lot of people go, why are we talking about pet stores and students taking classes and earning degrees? This is supposed to be a database class. We're in computer science. We're supposed to be learning about databases. You are, actually. This is the way that you think through the design process to actually build it. So just keep that in the back of your minds. I want to kind of sort of go back to the PowerPoint because I want to illustrate a couple points here just to give you some of the foundational stuff for what I just talked about. So let's see. We stopped here on this concept of there being an entity type. Those entities are the pets, the students, the teachers. We identify these because we want to keep track of them as an object, because that's what's controlling which relationships we're keeping track of. And then we have those entity occurrences, which is every one of you. And the concept of that occurrence is that there's, how many do we have? 14 people. I have like 18 enrolled. We're only missing 4 people. It's not bad, but you know, I have extra people. Anyway, long story short, you guys are all occurrences. Well, what about, like, you know, when you go and get an inspection, or I don't know, some of you might be learning how to drive. Because you're international students, you come here. Everyone wants a car. That's the first thing most international students do is get a driver's license. Actually, that's an interesting concept. Because, well, in California particularly, you can't get around very far on the bus. It just takes too long. So a lot of people want a car, and cars are pretty cheap actually, compared to elsewhere. I don't know. Long story short, the concept of getting a driver's license is an entity. It's an application. It's a receipt. It's a license. The concept of a license doesn't exist. I mean, you get like this printed out card, ID card kind of thing, but is that really your license? It is in concept. If you need to put an object on a concept, it is. But driving is like a concept. So think, when you design a database, you have to think about the concepts as well as the physical objects that you're representing in the data. Because you have to take like this huge, I mean, take a picture of the world and put it on a piece of paper, which is what you're doing. Like, how am I going to take okay, so you can't capture everything about the world and put it on a piece of paper. So that's why we reduce it for databases. We reduce it down to entities, relationships, and attributes. We only have to capture 3 things about the world. Stick it on a piece of paper. And then we have to figure out, well, where does this database stop and that database start? And then that's where people start putting things in like containers or housing them together. As an example, I was talking about a pet store. I would not put that data into the university database. There's a clear stop and a start with that one. There's like 2 separate concepts. So the database that I would build to keep track of students taking classes to earn degrees, that would be like a totally different database than the car database at the DMV versus the pet store database. The DMV's got a huge database of all the people. In fact, that's a simple one. People who have driver's licenses, people who have cars have registration. We could model the database for the DMV quite easily. That's an easier one. Students registration, that's pretty easy too. So you look at the company and you look at the business. And this is why I'm saying this is really a business concept. And what the business is doing, you take a picture of that and you stick it on a piece of paper. And voila, you have a database when you translate that picture into the tables. So the first part of it is just capturing it. If you can capture it, you've got skill in database architecture. If you can visually see the components and be able to break them out into entities, relationships, and attributes, then you're on your way to becoming a database architect, because that's all they do. It's like the guy who envisions the house and says, you know, like the architectural design for a building. You know, they have the panels and the windows and everything. Well, this person like picked that stuff up and said the windows are going to be here, here, and here, and it's going to be this high, and it's going to be this wide, and it's going to fit on this little piece of paper. It's the same concept, but you're designing a database versus a house. In fact, I think database is a little easier. So we kind of covered most of the first part of the slides today. I just want to see if I missed anything. We did it with the tool set. So you would normally draw boxes, and this is a staff, and entity names go inside of the boxes, and we just saw that. We have relationships, those are those diamond symbols. And the relationship has a type. It's a meaningful association. Now, a lot of people will combine relationships and objects together, or they'll make duplicates of the same thing. Like students taking classes and students passing classes and students failing classes and students skipping class. It's really all like very similar relationships with the same class. So if you pass the class, fail the class, take the class, skip the class, like the class, don't like the class, whatever it is you have with the class as a relationship, isn't it all the same relationship? And those are different characteristics of the same relationship. So the difficulty in visualizing this is trying to figure out, is it all the same relationship, or is it more than one relationship, and how many relationships I want to put on there? That's where you get into the, if you keep it separated, you can see the duplicates better than if you put it all together. Because then you're just like, oh man, So we'll go through a couple of those patterns as we start looking more into this. The relationship type. This is not an entity relationship diagram. Obviously, hopefully you'll recognize it, that it's not at this point. It is an illustration to show you the number and the types of relationships. Yes? Pizza. Oh, okay. How many we got? 1, 2. Could you get some extra for me? We have 14. We get pizza? 14 people here. Okay. And can you get, what do you guys want? Vegetarian, chicken? Okay. What time is pizza showing up? What time is pizza? Oh. Okay. Okay. Perfecto. Wherever. Hey, we get free pizza today. Woo! Free pizza. I was worried about what I was going to do for lunch. Now I'm worried about when I'm going to take lunch. Because someone said pizza, now I'm getting hungry. All right, so we get free pizza. I wonder why. Huh. Anyway, maybe because it's first day. I don't know. Anyway, back to this boring stuff. This is not entity relationship diagram. This is illustrative purposes. What is this showing? This is actually kind of a cool diagram, though. We have 2. This is going back to the students and taking the classes. And we had 2 teachers. Well, here we have 2 branches. Branch B003 and B007. And we have a has relationship. There's 3 different relationships in here. And they're taking it, and they're associated with 3 different staff. So if this were into a diagram, it would kind of look like this. And here's another piece that our diagramming tool didn't do for us that you might have noticed. In this particular case, because we have what's called a binary relationship, one entity having a relationship with another one, so we only have 2 participating entities, which makes it binary. You don't have to know computer science for that one. We have no diamond. There's no diamond symbol here. Instead, we just have a line that's going from one entity to the other. And in that case, underneath it says the branch has staff. And this is done on purpose to kind of mess with you a little bit. I have been arranging things left to right because that's how I read English, left to right. Some people like to go right to left. There's no law that says you have to go right to left, left to right. In fact, it should be the same thing. If you have a relationship with somebody else, shouldn't that person have a relationship with you? Americans have a tendency to forget that part. You know, like this is a joke, so don't look at me so seriously here. You never go out with someone and think you're in a relationship, and then you discover that you're really not because that other person's cheating on you, or that other person is like not having the same relationship that you think you're having with them. I don't know, maybe it's just an American thing. I don't know. It's a joke. It's humor. It's humor. For everyone who's ever been in a bad relationship, you realize you're not in the same relationship. Like, sometimes you break the relationship because the relationship never existed. Because that person wasn't in a relationship with you. They just pretended. Or something like that. Anyway, joke, humor. Because it's relationships and entities and people. You know, it's like people who take a class. Let me put this into a reality. You guys can understand. Students who take a class who don't show up for the class. Are they really taking the class? If I'm the teacher teaching the class and there's no students in the class, I'm going to say that those students really aren't taking my class. They think they're in a relationship with the class, but in reality, I don't think so. So anyway, another example. Long story short, if they're both in the same participating relationship, then it should read both ways. If the branch has staff, then the staff should have branch. I don't know how many staffs have branch. For people who speak English as a first language, that sounds really weird. It's like, what? I don't own the branch, but I work there. I don't have it. That's because there's that, so we have this little arrow. So what ends up happening is when you use the line, and you're assuming that it's supposed to be read a certain way, And you have this little arrowhead that points in the direction that you're supposed to be reading it. So branch has staff, the arrow's going this way, which means it's supposed to be read this way, and it's flipped around. So you don't have to say staff has branch. No, the little arrow's telling me it's the other way around. Branch has staff. So you like to write left to right, right to left. It doesn't really matter which direction, as long as you put an arrow in there. If you're going left to right, you could leave the arrow out. No one's going to notice, which is kind of the ironic part of it. Or if you're putting the diamond in there, a lot of people won't put the diamond symbol in there because why? You're only connecting two together. You don't need those four top, down, left, or right. You don't need those four arrows in there, so leave it out. Just the same way as we had entity types, we have relationship types, and we have relationship degrees. 2 is binary, 3 is ternary, 4 is, I can't even say that, quaternary, whatever. 1, 2, 3, 4, I can say that. No, actually 1 doesn't work unless you have a relationship with yourself. And that's recursive. Yeah, recursive relationship is a relationship with yourself. Well, I would have one. You know, like the mama papa store owner or the sole proprietor. You know, I'm like owning my own pet store as an example. I could be the boss. I could be the employee. I'm also the cleaner of the cages. I don't own my own pet store, by the way. I don't like pets, actually, but that's why I always talk about pets, because I can't stand pets. I have allergies. Anyway, long story short, I'm on my own. If I'm the sole proprietor, the person who owns the pet store, I'm the boss. I'm the payroll person, the marketing person, the sales person, the cleanup person. I open the store, close the store. I do everything. So the relationship I have is with myself. So if I do something wrong, I go, hey, you did something wrong. Fired. Okay. You know, I get fired, hire myself back over again, because then I realize, I can't fire. You can't be fired. I'm the only one here. Okay, so anyway, you're just talking with yourself. I'm talking to myself right now. Getting delirious. I need pizza. Anyway. Here's another one, and the arrow's going this way. And then we have this made-up word. I've never heard of pones. Po-owns. That's like that example we saw on that website. It's a private owner, P-O, who owns property for rent. So private owner owns property for rent. So they made up this word in here and they stuck it in there. And then we have the 3 together. So I was trying to show you with the tool, but I couldn't get my arrows to work correctly, or couldn't get my lines. And then later I figured it out. But bottom line, staff registers branch with a client. Staff registers a client at a branch. The branch registers clients with staff. So if it's just a registers relationship, we know that the staff registers at a branch. And who's it registering? Clients. So it should be able to be read in all directions, theoretically, but the word may not necessarily make sense. You might have to change the translation of it. But the idea is you're not supposed to put too many words on here. It's a diagram. So you just put boxes and arrows and stuff. Here's about as high as you'll get. It's 4 participating entities. So we have a solicitor who arranges a bid on behalf of a buyer supported by a financial institution. That's a mouthful. If you get past 4 people hooked together, you've gone too far. Because, I mean, if you put 5 of them in there, it's really hard to say that in one sentence. Which means you probably don't want to stack it up like that. And the really cool thing is you never have to do one of these at all. You can always just do 2. You need 2 entities to have a relationship. That's about it. Technically, one can have one with themselves, but that's very rare. So you don't necessarily have to go too far. Multiple. And 4 is about as high as you're going to go. Here's our recursive relationship. I was talking about before with the pet owner, the store owner, who's also the employee, who's also everything else. If that's the case, then you can have the same entity type that participates in more than one or different roles in the same relationship. So relationships can be given role names indicating the purpose of each of the participating types. For example, here's a staff member who supervises. So you ever, I don't know, work at a place where you're the supervisor, but you're also an employee? Actually, I have a good example of that here. I'm the program chair for the computer science department, but I'm also a teacher in the computer science department. So apparently I'm my own boss. So I get to make up the rules. And therefore, I have a recursive relationship with myself. And I'm not going to fire myself. But unfortunately, I had to give myself an extra class this weekend. So anyway, it's okay. I'll just take off more time during the week. But I can still manage myself. So I just get to make up the rules. Versus managing, well, Donna, the other faculty member. Technically, I'm her boss. So I can tell her when she's going to take lunch or not. But she's a different person. But she's also staff. So we're all staff. One of us is a supervisor, one of us is a supervisee. If you put the different role names on here, you can identify, and basically this looks like two squares, but it's really a rounded. We actually saw that. Oops, it's missing. We saw that in that diagramming tool we were just looking at when I made a relationship with the same object with the same object. It's really a line, not a box. So it looks like. I think I still have it up, actually. Actually, this is a good question. Oh, here it is here. So if I took a room and I added a relationship to it, and I said that this relationship was, I don't know, uses, and I said that the room uses the room, that one kind of looks like that. It's a little clearer. Maybe this, here, I'll say this is manages staff. I'll say manages. Staff manages staff. That's what the example in the text. But this looks different. The one in the slide set, it looks like two boxes, one on top of the other, which is kind of deceiving looking. So those two boxes look kind of weird. Now, we've been talking about single relationships. We can actually put two of them in there. Actually, we can do it here. We can do it like this. Let's put two of them between students and degree. You might have you earn a degree. You can actually add another relationship here and say that you could do, well, what could you earn? No, you can't really earn 2 degrees. Maybe you can teach students, teacher designs. Let's say here, designs. At this school, we teach the classes, but we can also design the classes too. So in this particular case, I'm going to put 2 relationships in here. A teacher designs classes for students. And one teacher, actually many teachers can design many classes. And it kind of looks kind of funny because there's like 2 of them here. And it's kind of sort of like what the slide's showing you. You can have as many relationships as you want as long as they're separate. I could be a teacher and I could be teaching a student that I haven't designed the class though for the students. So this is more like teacher teaching a class. I could pull this out. Yeah, let's just leave it alone. This doesn't really make sense because I'm not designing students. I'm designing a class. So I could do this, huh? I could do here class. There we go. I can connect it this way. Teacher designs a class. Were you going to say something else? Uh-huh. Ah, yeah. You want to have a teacher design a class for a student. So I have a teacher that designs a class, and the class is 4. 4 is between class and student. There we go. That's possible. Now you're thinking. So it's all about the relationships. So you got to figure out what the relationship is connected to. So for 4, I have class and student. So which one? Classes? Right side. Oh, how did I do this? Oh, this is a recursive relationship. Manages between staff and staff. You just put the same entity for both 1 and 2. That way the arrow goes from one entity to the other entity. Yeah, that's the recursive relationship. But there's no limit. In fact, I can take this one here and connect it to a degree. The class, but via a relationship, classes lead to degrees, right? If you take classes, you earn a degree. So classes lead to, I don't know, that's a bad word, but, and then if that's the case, I'm going to say class leads to degree. Let's see if I can get this arrow. Oh, there we go. I got the arrow kind of going up this way. There we go. Classes lead to degree. Now, what do you mean when students take classes? So students earn a degree, and classes are for students. Really, students take classes. So I'm going to put takes in here. Takes classes. And then what ended up happening is this is actually not bad, especially for the first day of a database class. It's not a bad diagram, actually, when you think about it. It's fairly inclusive in terms of what the database is doing for storing student information. Know that, like, teacher can now have another relationship with something else. Like, say, for example, teacher participate. So teachers also participate in meetings. I'm going to put meetings in here. Meetings. So then I have my teacher, I have my participates relationship, and I have a meeting. So I click on participate, which is the relationship, and I'm going to connect them together now. So I'm going to go teacher. Oops, I just spelled participate. So teacher, participate in meetings. There we go. So what you're doing is you're taking sentence by sentence, going through a description of something, and you're going to take the description and put it out in terms of entity, relationship, and attributes. Now, it's a simplified version of the real world. This is a version of the real world, by the way. It's simplified because it only has those 3 components in it. But if we follow the methodology, those 3 components are all we need. Because what ends up happening is this is going to turn into a table, that's going to turn into a table, all these items turn into a table. These guys, oops, I left out something. I think it was named. Well, that's cool. It actually put in what used to be there. These guys actually turn into attributes, which are going to be rows and columns in a database table. Yeah? Yep. I was trying to do that earlier, and I couldn't figure out how to do it with this tool. I know I can do it by hand, and I know other tools do it. I was thinking that it had something to do with the connection, like to do a connection like this way. I haven't quite figured out how to do it, and at the break I'm going to figure out how to do it. So I just actually started using this tool a couple days ago, actually, when I was looking for software for this class, and I figured, usually I use OmniGraffle, and I figured, I don't want to make them, like, it's only a 30-day, the class is going to go past 30 days, and then I'm going to get stuck. So I know that there is a way of connecting more than one. Not quite sure, though, how to do it. I'll figure it out at the break, and I'll let you know. I'll answer that question after the break, because that's one of the things I'm trying to figure out. But I know that if there's a connect in there, I thought I had it figured out a few minutes ago, but it wasn't working. But in any case, this is what we're doing in terms of putting things together and representing the real world. And then what ends up happening here is this turns out into a database scheme. So this is our diagram. I still haven't figured out how to save the diagram outside of. This looks like the XML code for it. So what happens if I save it? I don't know. I'll figure this out at the I know you can save it, and I know you can load it back in. I'm gonna figure this out at the break actually. But for right now, you don't have to do, because as soon as we start in with assignment number 1, we're gonna want to save it because you're gonna want to bring it up later and use it. And if you save what you're doing is you're saving the file on your computer on your local disk. And it could be that I don't have it set for my local disk, but we'll see. And then, or you export it, and then you import it back in, or you open it back up. Did you figure it out? Or? Yeah, it's interesting. No, you don't need it. You would open it back up in the same tool. And then in order to submit it, you would export it out into a picture, diagram or a picture. It could be here, actually. If it brings up this little page, let's just see something real quick here. File, save as. Let's see, I'm going to call this diagram test. Let's see. It's a web archive. Let's see what it's saved actually. Test, that was my image file. That's the PNG I saved earlier. So I know that one works. And then this one here brings it up this way. Oops. Let's see something real quick. I'm going to save this one. I'm going to close this one. I'm going to open a new window because I don't want to destroy what I've got here. Open a new version of this. Diagram, open diagram file. Let's try this one here. No. It's not opening what I'm saving. Unless it ends up in documents. I don't see it in documents because I didn't give it a name. Why would it be opening? Let me figure out how to save it and open it. I'll do that at the break. I'm not quite sure how to do that. I don't want to waste time on it right now. But that's going to be important for us because we're going to want to save them and open them up later. And I know there's a way of doing it. I just haven't quite figured out how to do it yet, though. In essence, though, let me finish this up so we can go to lunch here and eat our pizza. But I don't think our pizza is going to be here yet. We can put in multiple relationships, as I was saying before. And then this one has 2 relationships: the staff that manages a branch, and branch that has staff. And the arrows, there's 2 different labels, and there's 2 different arrows going in both different directions. So you can put in multiple relationships that go into different directions with different labels on them, and they're representing, not all staff people manage the branch, but a branch has a manager. So it's a really different relationship than this one. So you can put in multiple relationships, that works just fine. And then on the attributes, you can put, and this is another interesting thing. We know what an attribute is now, I hope. Student ID, name. Attributes are things that describe the entities or the relationships. So you can have an attribute on either one. If you do that, they all belong to the same, and it's called attribute domain. But don't read into that one either. It means they're all text, or they're all numbers, or they're all pictures, or they're all something. We can have simple attributes, is what we've been looking at so far. Name, ID, simple one word kind of, or simple one storage. And then we can have composite, multiple different things go into it. A composite attribute would be sort of like your address. An address is a street, a zip code, a country code. There's like multiple different pieces that get composed that formulate the concept of an address, like a phone number, area code, prefix, country code. Everything you need to actually dial somebody is a composite because it's multiple pieces put together. We have the concept of single versus multiple valued attributes. And we'll see that with the tool set as we start looking at things. Single valued attribute holds only one value. And I usually use this for car color. The outside of the car, people say, what color is a car? It's gray, gold, silver. And what color is the inside of the car? Usually you'll say more than one color. It's kind of like black and chrome, or it's kind of like white and yellow or something, or two-tone, you know, because most cars aren't the same color on the inside. The outside they would say black, red, orange car. Oh, I like the green car. The inside, it's got brown and it's got red and it's got whatever. So it's multiple. So if it's multiple, it's multi-valued attribute. You store it a little bit differently in the database than you would a single, because you want to keep multiple values that are associated with the same attribute. Then we have derived attributes. Well, somebody's birth date gives you your age. You're seriously probably not going to store an age in a database, because every year you got to age everybody. And what time are you going to age everybody on their birthday? So you have to keep track of everybody's birthday, and then every year go in and change the database to make them a year older. Nah, you'll use a derived attribute, and the derived attribute is nothing more than storing your date of birth. Because at any moment in time, we can just take the current year and subtract the date of birth, and we get your age. So that's what they call a derived. This is just your terminology, your derived attribute. And then we have these keys, and I'm going to stop after the keys because I promised I'd get us out by noon, and it's noon, but it's I didn't know about the pizza. But anyway. Well, it should show up within the next hour, so I think it should probably show up within the next 15 minutes, maybe. And I don't want you guys to be the last ones to get the pizza. So. Anyway, it's all about the pizza. Keys. The last concept I'm going to introduce before we have the pizza is how we're going to keep things together. The key is any attribute can serve as a key. And then so for terminology, we have candidates. And that means any attribute. That's the minimal set of attributes that uniquely identifies each occurrence of an entity type. This is just vocabulary for you. I'm going to put it together after lunch. But minimal set of attributes, well, then that could be like, you know, name, student ID, address. Do we really need to keep track of all of your pet names? Then that probably would not be candidates. So as candidate is like a word used to describe people who apply for a job. These are the candidates that apply for the job. So you have some candidates that are tossed out. They're no longer candidates because they don't have the right background or the right work experience or something. So it's just terminology, meaning it's a potential key and it's a piece of information we want to store. You don't want to put garbage in your database that's not relevant. So there's a lot of that out there actually because people don't look at that. Primary key. There's no such thing as a secondary key, but there is a primary key. Primary key is anything that uniquely identifies you. At this school, your primary key is your student ID. Because most people, especially if you come from the same geographical background, you might have similar last names. For America, it's Bob Smith. How many Bob Smiths there are? Actually, it's not too many Smiths anymore. It's Johnson, Smith, Doe, huh? Yeah. But if you keep a track of a fake ID, not a fake ID, like a student ID, you know, like an ID, that's a number. Everyone only has one number. You can't duplicate the numbers. Outside of school setting in the United States, they use social security numbers. Usually you have to give like the last 4 digits of your social. Hopefully not, but that's how they keep track of you. And then you have this thing called a composite key. Well, that's just a key that's composed of 2 separate pieces of information. So you don't want to use your social, you could use like the last 4 digits of your social plus the first 2 characters of your last name or something. And then you have a composite because it's composed of 2 separate pieces of data put together. So anyway, now I hear noise in the hallway, so that other class let out. So I'm going to let you guys out. We'll pick up where we left off, and I'll show you how to save and open up files when we return. But let me stop this recording.